Welcome to This Explainer. Today, we're diving straight into a fascinating chapter all about computerized accounting and spreadsheets. We're going to see exactly how basic textbook concepts actually translate into the ultimate tool for handling modern data. Let's be real. Whether you're just tracking daily finances or analyzing massive, complex data sets, understanding how this software operates under the hood is a total game changer. So let's explore the spreadsheet canvas together.
Here's our roadmap for today. We'll look at the spreadsheet canvas, navigate the interface, tackle formulas and logic, cover data entry and formatting, and then wrap the whole thing up with pivot tables. Let's get right to it.
All right, before we do anything else, just try to wrap your head around this number, 16.5 million. Literally, that is the approximate number of cells available to you in just one single worksheet in Excel 2007. Specifically, we're talking about 65,536 rows multiplied by 256 columns. That is a massive workspace, giving us a practically limitless canvas to work with.
Okay, let's start with the absolute basics. Section 1, the spreadsheet canvas.
Now, you might be thinking, well, it's just a grid, right? But this simple grid structure is exactly what allows us to tame modern data. A spreadsheet or worksheet is fundamentally a matrix of horizontal vectors that we call rows and vertical vectors called columns. We use it to record, calculate, and compare numerical or financial data. Essentially, every single cell in this grid acts like a little container for information, just waiting for us to give it a purpose.
Moving right along, let's hit Section 2, navigating the Excel interface, and see how this all looks in the actual software. What's really interesting here is the interface redesign that came with Excel 2007. Instead of burying commands in endless drop-down menus, it introduced the ribbon. The ribbon uses horizontal tabs, home, insert, page layout, to organize tools visually, which makes them so much easier to find. Oh, and right up there in the top left corner, that's the Office button, which is basically your gateway for managing your workbooks.
And this setup brilliantly illustrates exactly where we input our core processing commands. On the left side, we have the name box, telling you exactly which cell is currently active. And right next to it is the formula bar. This is your command center. It lets you see the underlying data or the actual mathematical formula driving the value in whatever cell you've selected. It's really the brain of your whole operation.
So that brings us to the real engine of this whole thing. Section 3, formulas and logical functions. There's a really important distinction we need to make here between independent basic values that you just type in and derived values that the spreadsheet calculates for you. Say you input a quantity of 10 and a price of 20. Those are your basic values. But when you want the total cost, you multiply them together. That result, 200, is a derived value. It's the outcome of an arithmetic expression or formula. This is exactly where the spreadsheet starts doing the heavy lifting for you.
But if we want these spreadsheets to actually be smart, we need logic. A logical operator is a symbol used to compare two values, and it produces a strict result of either true or false. There's absolutely no middle ground here. It's not maybe or sort of true. By using logical operators like less than, greater than, or equal to, we are forcing the software to make absolute black and white decisions. And that is essential for complex data analysis.
Here's a great example of an IF function in action, actively calculating savings percentages based on those logical tests. The IF function just asks a straightforward question. Is a certain condition true or false? If it's true, it spits out one value. If it's false, it spits out another. So, if we're evaluating whether an expense total meets a specific threshold, the formula makes that strict true or false evaluation and then automatically assigns, say, a 5% or 10% saving rate. It's literally automated decision-making happening right on your canvas.
All right, let's look at how we polish all this up. Section 4, data entry and formatting. You've probably heard the old saying, garbage in, garbage out. Before we analyze anything, we have to make sure our data parameters are actually validated and updated correctly. Whether you're typing in month numbers, days or employees worked, or big financial figures, the golden rule is that data absolutely must be correct and in the proper format. Validating your input is the mandatory first step before any meaningful analysis can even happen.
Okay, so once the data is clean, how do we spot what actually matters? Instead of staring at a massive, monotonous wall of numbers until your eyes cross, use conditional formatting. This dynamically changes the appearance of cells based on their values. It visually answers critical questions for you in an instant. Where are the anomalies over the past 5 years? What's the trend looking like lately? It completely transforms raw data into a clear, readable map of information.
And now for the absolute game changer. Section 5, Analyzing with Pivot Tables. The chapter defines a pivot table report as an interactive way to quickly summarize large amounts of data, and honestly, that hits the nail on the head. This is your ultimate analytical tool for answering those unanticipated questions about massive data sets. When you've got thousands of rows of transactions and you suddenly need to know total sales by region or expenses by department over time, a pivot table does this instantly. And the best part, you don't have to write a single complex formula to do it.
It's literally a superpower for your data. With it, you can twist, turn, and summarize your numbers from any angle you want. The advantages are just incredible. You can query vast amounts of data with ease. You can collapse and expand levels of focus to see the big picture or drill down into the nitty-gritty details. You can even literally pivot the data, swapping columns and rows to totally change your perspective and then filter for the exact subset you care about.
But hey, even the pros hit roadblocks, right? So let's talk about troubleshooting common errors. Because when a formula breaks, Excel will tell you why, but it kind of speaks in code. So let's translate a couple of the most common ones mentioned in the text. First up, if you see a ref error, that's the one with a hashtag and exclamation point, it stands for reference. It means the spreadsheet is looking for data that simply isn't there anymore. The textbook notes this usually happens if you're linking to an unavailable dynamic data exchange topic or running a macro that drops a bad reference. Basically, you just need to check your system links, macros, and cell references to ensure they're accurately pointing to existing data that hasn't been accidentally deleted.
Then you've got the value error. Basically, this means you're asking the formula to do the impossible by calculating incompatible types of data. It triggers when the wrong type of argument or operand is used. For instance, if you try to multiply a cell containing the number 10 by a cell containing the word apples, the spreadsheet is just going to throw its hands up. You can't do math on text, so it gives you a value error. Always double-check your data types.
As you continue mastering this tool belt, I want to leave you with one final textbook challenge drawn from the chapter. Can you tell the difference between a relative reference and an absolute reference? Understanding exactly how data behaves in shifts when you scale your formulas is the secret sauce that separates beginners from true data pros. Think about how you anchor your own data and use that curiosity to take your skills to the absolute next level. Thanks for joining me on this explainer, and happy building.